Thanks for joining our webinar today on the simplest way to protect the interior of welded joints from corrosion. My name is Ryan Sears, and I'm the CEO of Line Pipe Systems. And we're broadcasting here today from our headquarters in Rancho Cucamonga, California. We formed LPS in 2017 to further develop some innovative technology that we had that solves one of the largest and oldest problems in pipeline infrastructure. And that is how to best protect the interior of welded pipe joints from corrosion and wear. Internal corrosion, I think, often gets overlooked. Corrosion in general costs the pipeline infrastructure industry in the United States alone over $7 billion a year. And 60 to 75% of corrosion-related pipeline failures are actually due to internal corrosion. So that's why we like to say here at LPS, it's what's on the inside that counts. My entire career actually has been focused on protecting the interior of assets from liquid corrosion. Okay. Previously, I was the president of a company that spent a lot of time lining the interior of tanks and pipes and pumps. But I think at one point I calculated I've crawled through over 300 tanks in my life, inspecting internal linings and installing internal linings. One of my first projects out of college was lining the interior of a hydrochloric acid storage tank for Dow Chemical in Northern California. And this is a huge tank, like 50-foot diameter, like 50 feet tall. You may not know, but hydrochloric acid would eat through steel in a matter of hours if it reached any bare steel. Well, that was 1997. Today, we're almost to 2021, so almost, 24 years. The lining's still in service. From what I know, there hasn't been any issues. And so, what I'm here to tell you really today is that the same thing can be applied to pipelines. The technology is absolutely out there to keep pipelines lasting, protected from internal corrosion for as long as is needed. One of the big reasons that pipelines are not utilizing some of the latest internal lining technology is because of the lack of a welded joint system. And in many cases, with a good welded joint system, the internal pipes can last 50 plus years for actually a lower cost in many cases than pipelines are currently lasting for when they go with over thick wall thickness or some other solutions, which we'll review a little bit later. For an overview of what you'll be seeing today, first I'll go through a little presentation on how it works. Then we're going to go to Belo Horizonte, Brazil, to our R&D center, where you'll see a weld demonstration and the actual product itself. Come back up here to me, and we'll review, basically compare our solution to some of the other prevalent solutions that are out there in the industry. And then we'll go back to Brazil for what is certainly the highlight of the show, and that is a hydro pressure test at an insanely high pressure of 2 pipe puffs that are not welded, which, as far as we know, hasn't been done before. So that'll give you a little idea of how well our products seal off the weld zone from liquid. If you have any questions during the webinar here today, type them into the comment box. We'll have maybe 5-10 minutes at the end. We'll answer some questions, and we'll also follow up the webinar with an email to everybody showing how you can schedule appointments with us to answer questions in a lot more detail. So great, we're going to try and keep this show a little more interesting than the typical Zoom calls that and video conferences you guys are on nonstop. So hope you enjoy it, and we'll go to our presentation now. Okay, so we actually have developed welded joint systems for a variety of internal pipelines. What you'll be seeing today is our system for thin linings, okay, which we define as internal linings that are less than 3 millimeters thick. Generally, we're talking about liquid epoxy, fusion epoxy, and thin polyurethane, which has a lot of advantages advantages, which we'll be doing a webinar on next on how effective polyurethane linings are for water and light abrasion slurry lines. We also have a welded joint system for thick polymer linings, for thermoplastic polyurethane and rubber linings. These are primarily for high wear slurry pipelines. It's actually where we first started developing the technology. And then we also are developing a welded joint system for unbonded pull-through polymer linings, such as HDP is the prevalent one. Then you'll see high-end thermoplastic materials such as PEEK that we withstand high temperatures. So there's our products. On the left, you've got the joint lock ring. On the right, you've got a sleeve. The difference between the two is the ring system comprises of two rings that are fit into each end of the pipe, and when the pipes are brought together, they form a seal over the weld zone. Whereas our LP sleeve is a single sleeve that's put into the end of one pipe, and the other pipe comes around it, comes over it, and the seal is formed with a single sleeve over the weld zone. So here we'll go to an animation showing how it looks. There's the LP sleeve, which is fabricated to fit the pipe ID. It is comprised of a steel body with an integrated insulating layer. There is an internal lining, which can be of really any material, depending on what liquid is transported. And then you've got the all-important bore seals, which are made out of a rubber material that seal up against the interior of the pipe lining. Animation of when you get to the field, insert the sleeve into one pipe, tack weld it in place, and the other pipe comes up around it. Here's a cross-section view. The sleeve going in, tack weld it into place. There's actually spacers, which this animation doesn't show, which spaces the weld gap that's desired, and the other pipe comes up around it. Is what you're looking at from the outside. You've got your weld gap to allow for a full 10 weld. You weld into the external cover of the LP sleeve. And Anicio, in Brazil, will show you some actual welding so you can see what it actually looks like. All right, now here's the joint lock ring system. Okay. This is, again, there's two of these for every joint, one in each end of the pipe. It's similar. You've got the joint lock ring steel body with an integrated insulation layer. You've got the internal lining, okay? You've got the bore seal, which seals up against the internal pipe liner, and then the big difference with this versus the LP sleeve is you've got the face seal that's on the face of the ring. So the ring is, when it's inserted, it protrudes slightly out of the end of the pipe. These can be inserted in the field or in the shop, or for instance, in a double jointing rack. So when they're inserted, they're actually protruding out of the end of the pipe, and when you bring the two pipes together, the ring faces touch, form a seal at that face seal gasket, and then you perform your full penetration weld. Cross-section view, rings go in, bring the two pipes together, okay, which compresses that face seal, and you perform your full pen weld. There's again a cross view of what you're looking at from the outside. You're ready to weld when the two faces of the rings are completely touching. All right. Now we are going to go to our R&D center in Brazil. I'll introduce you to my partner and co-founder and Chief Technology Officer of Line Pipe Systems, Jose Anicio de Oliveira e Silva. This guy called me about 5 years ago, screaming into the phone. He had found out what we were working on, and was screaming into the phone, telling me that what a huge opportunity there is. He was working on a run-of-mine slurry pipeline And we had something posted on the search engine where you found us on welded joint system for rubber line pipe, which we were working for at the time. And so he thought it was just a fantastic idea. We talked for a while, and here we are today. So here we go to the R&D Center in Belo Horizonte, Brazil.
Hi, my name is José Anísio. I am the Chief Technology Officer of Liner Pipe System, and we are speaking from our Research and Development Shop in Belo Horizonte, Brazil. Before we explain our system, a little background about my experience. I have been working with pipeline construction for more than 35 years in several different positions, from inspection as a client, as a contractor, as engineering manager of very large pipeline construction projects. During this career, I have become very familiar with the constructability issues, because we all pipeliners understand that problems arrive every single day. The problems walk into our offices, and we have to be ready to understand the problems and to provide the proper solution. The first challenge, and most obvious, was to provide some protection from the temperature, to protect the liner of the pipe from temperature. And this we achieved incorporating insulation layer into a ring system that protects the internal lining of the ring from the heat, from the weld temperature. Okay? This was the first challenge. But this was not enough, although the most obvious challenge. This was not enough, because we also needed to make sure that after we weld, we had the parent matter of the pipe completely sealed from the liquid that was being transported by the pipeline. And then we have to develop sealing systems to achieve that task, to complete that, to overcome that challenge. We came out with a ring to be inserted into each one of the pipes to be welded. The ring has an integrated insulation layer that is asbestos-free and that is completely secluded from the flow completely isolated from the flow of the fluid that comes in the pipe. We have a sealing system in the face of the ring where it matches another similar ring to the next pipe to be welded, and this seal, these two gaskets compressed against each other, they effectively seal the possibility of leaking fluid to the weld zone. We also have another seal, which is a bore seal, which seals the ring against the liner of the pipe that is welded. So we have the ring is completely sealed both in the back and in the front, preventing the fluid to get in touch with the parent metal of the pipe. We also came out with a sleeve, which is based on the same principle. In other words, we have an insulation layer that prevents the heat of the weld to affect the liner, and we have bore seals in both ends of the sleeve. Both the sleeve and the rings are lined with material which is the same or compatible with the material that lines the pipe. I mentioned the challenges of design, and one of the biggest challenges was to design something that was practical to be used in the field. We could not come out with a contraption that you take forever to install, that you cost enormously. So we have to come out with an economic and practical way of achieving our engineering goals. As you can see here, we have systems for a small pipe. This is for a 6-inch pipe. We have systems, both ring and sleeve, for big bore pipe. This is an 18-inch sets for 18-inch pipe. 18-inch is not our limit. We can go much larger pipe. 6 inches is also not our lower limit. We have some system designed for 4-inch pipe. Again, we designed something to be used in the field the normal way the pipelines are built. In other words, every single operation, every single pipeline construction operation performed in a pipeline that uses our system is performed the same way as if it were a bare pipeline. Okay, we are now going to demonstrate the insertion of an LPS sleeve into an 18-inch pipe. As the pipe is lined up, welding may proceed using the conventional welding process that's used everywhere in pipeline construction. In this case, we are using stick rod, cellulosic stick rod. Also, we could use other welding process. The system is not dependent on the welding process used. You may weld, please. As I mentioned before, our system for welding lined pipe is comprises a sleeve or a pair of rings. They are interchangeable, except that the sleeves may be awkward to use in some tying occasions because of the need of displacing the pipe axially to insert a pipe onto the sleeve already inserted in the first pipe. With rings, with a pair of rings provided with the joint that seals the interface between two rings, we do not have this issue. And the welding, the lining up and welding may be executed in the same way as it is executed in bare pipeline. We use here commercially available external lineup clamp that not only aligns the pipe, but also draws the pipes against each other to compress the gaskets and make sure that the system is perfectly sealed. Can you proceed, please?
LPS headquarters here. Hope you enjoyed viewing the weld demonstration, and hopefully it got a little jazzed up from the music we had there for you. Now I'm going to do a comparison of our products, our technology versus other prevalent solutions. Okay, so we're primarily talking about water lines and light wear along slurry lines. Primarily what we see in the industry for the joint solution is a robotic internal joint coating. Mechanical joints can be used as well, bolted mechanical joints, but you don't have to deal with a weld. You also have HDP pull-through liners, which are prevalent, particularly for smaller diameter pipe. And you've got bare pipe with corrosion allowance. compare against the robot. When it comes to coating a weld properly and getting a pinhole-free lining over a weld, it is very challenging. Here you've got some photos of some that are actually probably a bit excessive. And there's my pointer going on here. So you see the weld penetration here, and you see some weld spatter here. So it's something that I know the robot joint coating companies are very concerned about, and often they try and get weld methods, change weld methods so that they can avoid having this excessive penetration. With our system, it doesn't matter at all what the weld penetration looks like. And
The sound back. Okay.
is it back?
Yes.
Sound back? Okay, I was just told that the sound was gone. Okay now?
Yeah.
Okay. All right. So, sorry about that. But, yeah, obviously with our rings and sleeves, they're coated in a shop setting, so you don't have to totally control and QC in a shop, and you don't have to worry about the weather conditions. Due to some of these quality issues which pop up, and just the overall speed of the robot, it's important to understand that the coating is done after the welding, obviously. So the robots are usually, you leave tie-ins open for a long string behind the mainline weld crew, while the robots are coating all of the joints. And it's well known that they can't come close to keeping up with the mainline crew who might be welding 1.5 kilometers per day, while the robot can maybe do 500, 600, 700, 1.5 kilometers a day. The robot can do maybe 500, 600, 700 meters a day, so they're always falling further and further behind. And you can't close those tie-in locations until the robot has coated the joints and everything's been QC'd properly. So in many of the recent projects, we're talking 30, 40 kilometers behind the mainline crew, schedule that could be delayed months and cost overruns of often tens of millions of dollars. Now we'll compare our system to bolted mechanical joints. Bolted mechanical joints work fairly well. They have a tendency to leak. They're very costly for higher pressures. Usually not surrounded against bearing mechanical joints because of this leak potential. A lot of places have policies against that. And you're really not going to see them used for long distances very frequently. The HDP Liner. When they came out with this a long time ago, this was the best solution to the problem. Really, it's primarily used on 18-inch and smaller pipe. You do sometimes see it in larger pipe, but the cost go up dramatically as you get the larger diameter pipe. There's some other major issues, and one is that pigging is not recommended. It stresses the liner and can cause it to sag off the pipe wall. So, particularly if you want to monitor the pipeline using an intelligent pig, it's really not recommended. They can get stuck because the liner might contract a little off the pipe wall, and again, it just causes undue stress. It's not needed on the liner. Complex and time-consuming pipeline repairs. It's very complicated. What they generally do is they'll build a 500 kilometer section to pull the liner through that section and flange it on each end. Well, if you have a repair, you can't do much with it. So they're also just not bonded to the pipe wall. So most of the situations we know, it's not a question of if build collapse, it's when, and generally in that 15, 20, 25 year time frame, they will relax off the pipe wall. It'll be an issue. So it's not yet proven to be a really, really long-term solution. Then you got us versus bare pipe, which is probably one of the most prevalent solutions, which is no real solution, but let it corrode and add additional wall thickness to allow for corrosion. Corrosion inhibitors are sometimes used, really somewhat spotty, unpredictable, and challenging. Challenging to get work properly. Most companies will not choose those certainly for water pipelines. Now when you turn to our solution, it's simply when the weld is done, that's it. There's nothing that you need to do afterwards. Once it's been NDE'd, that's it. So really you insert the sleeves and rings ahead of time. So definitely keeping up with the mainline crew. So it really is truly the simplest solution. This is a little bit of information on our long-term performance. You'll see here in a minute a hydrostatic pressure test in Brazil, which shows that our innovative seal design completely seals off the weld zone from liquid at any pressure. It actually utilizes the pipeline pressure to achieve a seal. So the higher the pipeline pressure, the tighter the seal. That's one of the most important parts. There's other technologies out there that really can't do that. Also integrated into our design. It's a flexible design, so it takes into account pipe out of roundness and fluctuations in pipe inside diameter. The lining integrity. We've done extensive testing, and you'll see some of it. I think we just did see some of that. Some of the testing we've done on the inside, and our design is again an innovative design that really keeps the temperature from affecting either the sleeve or ring lining, and also the holdbacks on the parent pipe lining are farther back from other solutions. So the weld temperature does not come close to affecting the integrity of the lining. Our system also permits standard NDE procedures, RT, UT, AUT, and we've passed lots of ultrasound and radiograph tests, so they really integrate with the weld, and there's no issues there as long as the inspectors know what they're looking at. So with that, we're going to go back to Belo Horizonte, Brazil for what I think is definitely the highlight of the show, this hydrostatic pressure test, and I think you guys will find it exciting, at least you pipeliners out there. So sit back and enjoy, and we'll be back in a bit for Q&A.
We are now going to demonstrate how we test the tightness of the sleeve of our part of our system. I would ask Ezekiel to install the other pump on the test jig around the sleeve so we can pressurize it. Please, Zeke. Okay. As you can see, the sleeve is loose, just assembled. That's not welded. We are now ready to proceed with the hydrostatic test or tightness test of the sleeve. This is a pair of 6 inches Scavely 80 pipe. The yield strength pipe allows us to pressurize it. If you keep to the 90% limit, it will be around 280 bar. 100% of yield strength will be 320 bar. So again, this pipe is just the 2 pups and the sleeve, no weld, nothing, just a mechanical assembly. And then we are going to test it, to pressurize it. Kilo. That 293, 300. Well, I don't like to be funny, but I think that we just have another way of building pipelines. Have an anchor block and use our sleeve. Use the LPS sleeve, and that's it. Not need to weld.
Good job.
You can have a closer look. Of course, it will be very difficult to extract this sleeve from these 2 pups right now, because it should have been pressure formed under more than 300 bar. That's, as we say here, this is an insane pressure. It's not the kind of pressure that you see in your everyday pipeline. But yes, the LPS sleeve, LPS system can withstand this pressure without leaking, without letting water pass or fluid contact the parent pipe at the weld area.
Very well.
All right. Well, back to us. I hope you enjoyed that impressive hydropressure test. I'd like to reinforce that Anicio was kidding in saying that we didn't need a weld. We still obviously need them, but that does actually, improve the. There was a weld failure. Literally, our sleeve system and ring system would prevent it from leaking. Now we're going to go to Q&A session, and so let's get some. And I'd like to apologize actually for the sound. I've been informed that the sound was not very good here. We did a bunch of testing before, and it seemed fine from our pre-recordings. Audio does always seem to be the thing that ends up getting you.
On your microphone.
Anicio, please turn on your microphone. You are on live now, and we are going to do the Q&A section. So we are getting the questions. Let's see here. I will go ahead and get the question for you. Okay. So let's see here. One of the first questions is, what's the material of the gaskets and seals? We use different materials that are proprietary, but rest assured they are all prevalently used, and they will resist whatever liquid is transported through the line. So whether it's from water lines or if it's high temperature lines or chemical lines, the gasket materials will be the optimal material for that application. Another one is regarding NDE, RT, and AUT going to be used for the weld inspection. I did touch on that a bit. Yes, they may be used. And Anicio, I see you're now on. Maybe you want to answer that question. Yeah, so we yeah, we can hear you. Yep. So another question, what's the largest diameter pipe that we can work with? Oh, okay. So it sounds like people are not able to hear Anicio. Is that the case? Unfortunately, we don't have any way. No sounds, it says. Okay. It says there's no sound. Jose Luis. Is there any, let's see. Hold on one second. We're going to reach out to somebody else out there. Okay. Yes, okay, they can't hear me, so then I'll answer the questions. Anicio, no. Okay, so sorry about it again with the sound. We're our first webinar, we're trying to get it dialed in. So Anicio answered with UT and RT. We've done manual UT, we've done plenty of x-rays. There's really no issue as long as the inspector knows what they're looking at. And we are doing a study right now on AUT for a project. So we'll have, that'll certainly possible. We just have in the process of doing that now. So one of the, another question is, what's the largest diameter pipe that we've used? Well, largest we're working with right now so far is under 30-inch, but our sleeves and our rings are absolutely, actually very easy to make. They're, you can make them rapidly to any size. The sleeves are not machined, so they're flexible enough, and really there's no size limit. We're currently quoting jobs even up to 56-inch diameter. Another question that we've done a vacuum test. We actually have not done a vacuum test. That would be, we've been asked that before. It's not the easiest thing to do. We will absolutely do it, and we don't foresee any issues because our seals are integrated and locked into the sleeves of the rings. So there's no reason to think that they would be pulled out by any vacuum. Answer that question. So let's see, what were some of the other questions? What's the highest acceptable temperature in the internal lining? The internal lining for the rings and sleeves can be changed based on the application, so based on what's being transported through the pipeline. And all of our materials are rated to withstand far in excess of the temperature they'd be exposed to. So we use epoxy materials, polyurethane, we use some other exotic materials, rubber thermoplastic polyurethane. The weld temperatures, depending on the weld method, can range from 100 C up to say 120, 125 C. That you'll get exposed to the lining material, and the lining materials easily withstand that we use. So let's see what other questions here. Can you anything else there, Louise? Considering pipe dimension allowances, diameter, thickness, roundness, established by pipe fabrication codes, how do you guarantee proper adjustment installation of rings and sleeves? So the rings and sleeves are designed to seal properly within API 5L dimensional tolerances. If Benicio could talk, he would discuss this more, but we are recommending that they're within Appendix J, which calls for a tighter outer roundness specification, but certainly within the diameter and at least the Appendix J outer roundness specifications for API 5L, we achieve a seal, and the weld quality is fine as long as the pipe's within those tolerances. Let's see, another question. How much time do we got left?
We're on time.
Okay. I get a question, which tests under operating conditions, flow of fluids, and which fluids apply? So our system is really, as I mentioned at the beginning, we designed it for any type of fluid, if I'm understanding the question correctly. We can adjust the pipe lining, and then the ring and sleeve lining to whichever is the best material suitable for the application. Which tests under operating conditions? We have several trial installations in where a new company with a new technology been in service for a year or two, and some high temperature applications with brine and with water, normal process water, and Got it. So, okay, looks like we're about out of time. We'll be sending an email out with a link to this webinar for everybody. We may redo the sound depending on how bad it is. I've got some comments that the sound didn't come through very well. I apologize for that. But thanks for coming anyways. And so for those of you up here in the United States, or if you're celebrating Thanksgiving, I know it's been a challenging year to say the least, but there's still a lot to be thankful for. We'll send an email out, like I said, and you'll have a chance to schedule meetings with us, and we look forward to speaking with you and seeing if we can help solve your pipeline corrosion problems. Have a great day.